So today, we're going to be talking about a new pulsar discovered by the U.S. Naval Research Laboratory. In the Sky Report, we will talk about some unique celestial objects that have been in the night sky for the past following days. And finally, we're going to be talking about some stellar winds from a historical supernova that exploded in the night sky almost 900 years ago. All of that and more will be covered. This is Interstellar Insights. Alright guys, so to start off this episode, we're going to be talking about a new pulsar that was just observed by the United States, just US, I'm being really fancy here, the United States Naval Research Laboratory in the past week. So, for those of you that don't understand what pulsars are, because this is a very, I guess we call it complex subject, sure, we'll leave it at that for people that are into astronomy. I'm sure everyone who's listening that's into astronomy knows what a pulsar is, but if you want to know what a pulsar is, we need to first understand what a neutron star is, because all pulsars are neutron stars, but not all neutron stars are pulsars. It's like one of those things, like, you know, with squares and rectangles and all that. But anyways, so I'm sure to those who are listening, you guys all know about like different star sizes. So you know, there's like medium giants, which are like about the size of the sun. And then there's super giants, which are, you know, like Betelgeuse. They're red. They tend to be older and they tend to consume more fuel, more hydrogen being converted into helium. But anyways, when these stars reach a kind of critical mass point, because they keep turning hydrogen into helium, but these elements, you know, they keep on getting denser. You know, because that's where all the elements come from on the periodic tables from this process of nuclear fusion in the course of the stars. But anyways, once this certain point where the star's core reaches like a critical mass, it starts to collapse on itself. So for like our medium-sized stars, like we're talking about like the sun here, when the sun eventually runs out of fuel, and going back to what I said about the collapsing of the stars as a result of mass, it's part of that as well as you know, it's a very dense, you know, it's dense ball of fire. But anyways, part of that's also just the lack of hydrogen that's being able to get converted into helium in the core. But anyways, I'm sliding everywhere. But anyways, let's start off with like the smaller stars like our sun, you know, like medium giants. When the sun runs out of fuel, when it reaches that point, it'll collapse down to a white dwarf, which is much smaller than like the current state of the sun, but it is so dense. Like if there were a golf ball of it, like golf ball sized massive white dwarf core on Earth, like our Earth would be destroyed. That's how dense we're talking here. Now, for the bigger stars that, you know, like your red supergiants, like we're talking maybe a little bit smaller than Betelgeuse, maybe Betelgeuse I can see. But those supergiants, when they collapse, they're going to collapse down very densely. And the only thing that can hold back this collapse is going to be neutrons at the atomic level, which is where neutron stars come from. Because they're smaller than what they originally were. I'd say they're somewhat bigger than white dwarfs, but they are so dense for how small they are. And then pulsars, which are a kind of neutron star, like we talked about, are just neutron stars that emit pulses of electromagnetic radiation. So, I'm assuming everyone on this podcast knows what a lighthouse is, but think of a pulsar like a lighthouse. As it spins, it's, you know, it emits pulses of electromagnetic radiation, which we can pick up here on Earth, which is kind of funny when it was initially discovered, because they thought that pulsars were actually extraterrestrial, like they were signs of life, when in reality they were just these, you know, big old stars, very dense, much more denser than white dwarfs, by the way. They were just emitting these pulses of electromagnetic radiation. And then, even though this isn't really covered for this story, I guess we'll go even talk a little bit about more bigger stars. So where they like red supergiants, and then like, you know, your massive, really massive, like much bigger than red supergiants. Like these stars have been around since like the dawn of time. Like I think Stevenson is that old. The star. It's got a bunch of letters. I don't remember it, but the Stevenson star definitely, when it collapses due to losing fuel, the neutrons that put up the pressure and force against the collapsing star won't be able to stop the collapse, and it cannot hold it back, and then the object will just get very small and very dense, at which point it forms a black hole. So, and at that point, it gets very theoretical because the gravity is so strong, it is bending, the fabrics of space-time, which was proven by Einstein in theory of relativity, that there is everything on space is like on a plane of space-time, but that's theoretical Einsteinian physics. I won't go there. Take it for a grain of salt because it's theoretical, and they're still trying to understand black holes, because black holes were discovered like 50 years ago. Well, I mean, they've been speculated for longer, but like Stephen Hawking, who I guess people would consider kind of the person who discovered through mathematical calculations and quantum physics, discovered black holes. But anyways, that's all the science behind us. Let's go to actually what's going on. But so this new pulsar was discovered at the U.S. Naval Research Laboratory, like I said, and this pulsar is, I'm going to rephrase this. This pulsar is currently in the stages of being classified by experts as a pulsar, because this pulsar supposedly, in quotation marks, was discovered in the glimpse, the glimpse-CO1 stellar cluster, which once again, very poorly named. But this pulsar was the best candidate from that stellar cluster to be considered a pulsar, because that stellar cluster, researchers found out, had a ton of them. Supposedly, because they're still trying to classify it, but this pulsar is the strongest candidate at being called a pulsar, which is kind of silly since I've been calling it a pulsar for the past 5-10 minutes of this segment. But anyways, they're calling this very strong candidate for a pulsar, glimpse-CO1A. I'm just going to call it pulsar A or whatever. But they're trying to classify this. The leading experts are trying to get this to be officially designated a pulsar. And this was actually observed, I think, at the National Radio Astronomy Observatory, I think out in West Virginia, I believe. I forget. It's like radio astronomy, national something. I don't know. I have to do more research about that. But out in West Virginia, they use tools from there, mainly radio image surveys and imaging. And they were able to capture pulsar A emitting, the electromagnetic radiation from its pulse for like a millisecond, which led them to this discovery. But right now they're still, like I said, classifying it, and this is really good for the astronomy community, because pulsars are actually going to allow us to understand how matter behaves under these very extreme gravitational circumstances, because black holes, I mean, they are the powerfulest gravitational force, but they're so powerful to the point that we don't even understand what's going on. But pulsars and neutron stars at this point are very good for that, and they'll help us understand the behavior of matter under these strong gravitational circumstances, because most of this cannot be replicated and observed on Earth. So yeah, that's the new pulsar that was discovered this week. There's more research being published. I believe that's getting published in the Astrophysical Journal. If you guys are interested, go in, take a look over there. When it'll officially be called a pulsar. But let's face it, it's been a pulsar. But anyways, that's the end of this segment. Let's go move on to this week's Sky Report. Alright guys, so let's get into this week's Sky Report. Reminder that all of these times are going to be in Eastern Daylight Time. So if you don't live on the East Coast, figure out what it is in your time zone. I'm not going to do it because I have to read out all of these times, and that is a pain. So anyways, let's start off with tonight and what's going on in the night sky. So NGC 4631 which astronomers have found out is a really bad name and gave it another name known as the Whale Galaxy. That galaxy, the Whale Galaxy, will be shining with a magnitude of 9, and it can be found 6.5 degrees southwest of Cor Caroli, which is the alpha star of the constellation Canis Venatici, which is the Canis Venatici itself, the constellation, will be to the left of the handle of the Big Dipper. So, kind of, that was in reverse, but to put it in the right perspective, when you're in the night sky, or looking at, you're not an astronaut, looking into the night sky, look for the Big Dipper's handle at the tip, and then look for the Canis Venatici to the left of the handle of the Big Dipper. Then look for Cor Caroli, which will be the alpha star in Canis Venatici. And then from Cor Caroli, look 6.5 degrees southwest. And then you can find the Whale Galaxy with a magnitude of 9 in the night sky. And this will, I believe, with this current method of locating the Whale Galaxy, it'll be, like this until midnight. And then, morning hits, and then they're moving in the night sky. But anyways, that's what's happening tonight in the night sky. July 11th is Slurpee Day, so there's obviously going to be a Slurpee Galaxy. I'm just kidding. Do it anyways, because this is not a show about 7-Elevens. This is a show about night sky. So what's going to happen tomorrow is that Ceres is going to be passing near a global star cluster called M54, which is not a bad name. Anyways, M54 can be easy to find because it's going to be in Sagittarius, the Archer, mainly the teapot asterism. Words are hard. Asterism of Sagittarius, which will be 20 degrees to the south, in like the southern in your direction, but that'll all be depending on your observing location. But anyways, once you find M54, Ceres is going to be 1 degree northeast of M54. And actually, if you won't be able to look at this in the night sky for Thursday night, tomorrow, Ceres is going to be passing by M54 for a couple of days. So it's not the end of the world, but that is what's going on July 11th, aka Slurpee Day, aka go get free Slurpee from the nearest 7-Eleven ASAP. Anyways, on the 12th of July, this Friday, the moon will reach apogee, which is the farthest point from Earth at 4:11 a.m., which will place the moon at 251,259 miles away from Earth. And then Mars and Uranus are going to pass each other early in the morning as well, along with the moon reaching apogee. And then they will be 0.06 degrees of each other. That's how close it's going to be. And to kind of find them passing each other, first off, locate Mars, as that'll be easier to spot. And, it's a red planet, so it'll be red in the night sky. But anyways, Mars can be found 8 degrees off of the Pleiades star cluster in western Taurus, that region of the constellation, because they're kind of intertwined. But anyways, it's going to be far west in Taurus. And Uranus, once you find Mars, Uranus is going to be like this. I'm going to put this in quotation marks, flat, because Uranus is not flat at all. It's going to be like a flat gray star that'll be in the night sky, and Uranus will be shining with a 5.8 magnitude of brightness. So anyways, that's what's going on in the night sky. And then right now I'm going to tell you, times for sunrise and moonrise. So tonight, sunrise is going to be at 8:30 p.m. Moonrise happened this morning at 10:14 a.m. And moonset's going to be at 11 p.m. Tomorrow, Slurpee, there's going to be a Slurpee moon. No, I'm just kidding. There's not going to be a Slurpee moon. Sunrise is going to be at 5:42 a.m. Sunset's going to be at 8:29 p.m. And moonrise is going to be at 11:14 a.m. And moonset's going to be at 11:44 p.m. Now for the 12th, Sunrise is going to be at 5:42 a.m. Sunset's going to be at 8:29 p.m. Moonrise is going to be at 12:13 p.m. in the afternoon, and I don't have a time for moonset because we can't find data for that yet because that's too far out. But anyways, for your moon phase for the rest of this chunk of the week, it's going to be a waxing crescent, so that's coming off of the new moon that happened last Friday after the 4th and seeing the fireworks galaxy. But anyways, guys, that's this week's Sky Report. So let's go move on to our next segment. Alrighty, guys, so let's go and talk about kind of our last major portion of this episode. So we're going to be talking about some stellar winds from a very old supernova, which at this point is a nebula because of how old it is. But anyway, so a little bit of a history lesson. So this supernova we're talking about, I'll reveal its name later, but this supernova, we'll just call it supernova, was observed in 1181 in Japan during the Genpei War that occurred for 5 years from 1180 to 1185. And there's records of it exploding in the night sky in Japan, Korea, and China by astronomers. And this supernova is unique because in this supernova explosion, there were two white dwarfs involved that collided to cause the supernova, but they formed a guest star, which is a term used mainly in like Chinese astronomy, kind of at the time, Chinese astronomy in East Asia. But the term guest star, it's a term that refers to an object that just appears in the night sky in a region of the sky where there was nothing there before, and then all of a sudden it would just mysteriously disappear. So, after these two white dwarfs collided, supernova dimmed a lot because we've been having trouble spotting it in the night sky, from after the explosion all the way up to now, with this supernova being called, and the full name is Supernova Remnant 1181, but they've decided to give us a nice abbreviation, just call it SNR 1181, which is much nicer, and that naming is actually very logical. But anyways, this supernova was recently rediscovered, in 2021 with its location unknown because it dimmed so much. And and many astronomers and astrophysicists, they pinpointed the location of this nebula in the Cassiopeia constellation around that area. So that's where they were able to pinpoint it. And this supernova is actually very strange because usually when two white dwarfs collide, they should instantly explode and then they'll just disappear into the supernova, and then eventually, once it cools down, they'll just become part of the nebula. But in this case, what actually happened was that the two white stars, they collided and they just formed a completely new white dwarfs. These two white dwarfs collided into like a one new singular white dwarf. And then what should have happened, which is kind of the point that I want to mention about with stellar winds, is that it was expected to immediately create stellar winds. But scientists have discovered that this process might have started very recently, maybe about 20 to 30 years ago, but which doesn't make sense because usually that starts as soon as the two stars collide. But they discovered this after they were able to map out the inner shock region of where the supernova had exploded very well, because if the stellar winds were created immediately, then astrophysicists wouldn't be able to get those calculations to figure out what it was, yet they were still able to for this supernova, which is very strange. So it's very unique, very special, and to this day, after this kind of discovery, which has been, minus it being initially discovered the location back in 2021, the discovery of the weird properties of this remnant and nebula, which, by the way, I should have defined this, but nebula is just the remains of the supernova. So like my profile pic, the Eskimo Nebula, like that was a remain of a supernova that exploded a long time ago. I don't know exactly, but anyways, a little bit sidetracked off there from this talking about what a nebula is. Research is still being done regarding this supernova because this is very it's unusual. I wouldn't say it was a bad thing, but it'll help us study more into behavior of stars and why in this particular case the two white dwarfs that collided formed one white dwarf instead of just exploding and disappearing into the ruins of the supernova. So yeah, that's the end of this segment. Let's go into astronomy trivia. Alrighty guys, so let's go into this week's edition of astronomy trivia. Before we go to this week's question, I just want to talk about what last week's answer was, which was I believe the question was, who was the first person to enter space? In which case that'd be Yuri Gagarin, who was a Soviet cosmonaut who entered space on April 12th, 1961, after he launched aboard his spacecraft Vostok 1 from the Baikonur Cosmodrome, which is in modern-day Kazakhstan. So for this week's edition of Astronomy Trivia, the question is, what rover suffered from power issues due to dust covering its solar panels? Okay, I want to read that to you one more time. What rover suffered from power issues due to dust covering its solar panels? Right. I'll go post the poll for this on YouTube and Spotify. It'll be 4 answer options. Figure out which one. But yeah, that is this week's edition of Astronomy Trivia. Let's go close out this episode of Interstellar Insights now. Alrighty guys, so sorry if the audio sounds a little bit weird. Right now the microphone is being kind of finicky, so I don't know why. There's a sudden kind of weird, reverberations in the background. It just makes my voice kind of sound weird compared to the rest of the podcast, this episode. But anyways, this is the end of this week's edition of Interstellar Insights. So there's going to be another episode posted regular time next week. No funny business there, unlike this week. But so nothing new, just regularly posted. So if you like this episode, feel free to give me a like and subscribe if you're on YouTube, or if you're on Spotify, feel free to give me a follow, and that's another way to support my podcast. And well guys, this is Michael signing off.